0.7. Here we go. The integral of this. So, what do we got here? This cube looks a little messy. If that was just a u cube, that would be nice. So let's say u would equal x plus 5. So du would equal dx. And so this would become the integral. So that x squared is not going to cancel. So I better have something to put in for the x squared. So what is x? Well, x would be, solving for x here, u minus 5. So I'd have u minus 5 squared over, and dx and du are the same, over u to the third. Well, u minus 5 squared is going to be u minus 5 times u minus 5, which is u squared minus 10u plus 25. So I'm going to have the integral of u squared over u to the third, which is u to the minus 1. Then I'm going to have minus 10u over u to the third, which is minus 10u to the minus 2. And then I'm going to have plus 25 over u to the third, which is u to the minus 3 du, which is going to be, so 1 more than u to the minus 1 is 1 over u, so that's ln, absolute value of u, minus, and 1 more than minus 2 is minus 1, and divide by minus 1, so this can be plus 10u to the minus 1 plus 1 more than minus 3 is minus 2, and divide by that, so that's minus 1/2 u to the minus 2 plus c, which is going to be, now if I put x plus 5 back in here, I'm going to have ln of the absolute value of x plus 5 plus 10 to the minus 1 puts u in the bottom, x plus 5, and minus, and this is going to go squared in the denominator, so minus 1 over 2 times x plus 5 squared. Okay, the next one. Well, this is to the 1/4. With an x plus 1 a little messy, so I'm going to let u equal the x plus 1. So du is the same as dx. So this becomes, oh, and I got an x plus 2. So what would x equal? So u minus 1 is x. So I'm going to have the integral of x, which is u minus 1 plus 2, so that's u plus 1 times u to the 1/4. du is dx, so I don't have anything extra coming in here. So now I can distribute this, and this is going to be the integral of u to the 1 plus 1/4 is u to the 5/4 plus u, 1 times u to the 1/4 is u to the 1/4 du, which is equal to 1 more than 5/4 is 9/4, so it's going to be 4/9 u to the 9/4 plus 1 more than 1/4 is 5/4, so 4/5 u to the 5/4 plus c, and then we'll put back in the x plus 1, so it's 4/9 x plus 1 to the 9/4 plus 4/5 x plus 1 to the 5/4 plus c. All right, I don't like this mess squared, so I'm going to let that be u. So du would be derivative of 1 is 0, derivative of sine x is cosine of the 2x. But then I have to do the chain rule, which should be the derivative of 2x, which is a 2 dx. So this becomes the integral of cosine 2x over u squared, and dx is du divided by that, which is 2 cosine 2x. Fortunately, the cosine of 2x cancels. The 2 will come out, so I have 1/2 integral u squared, and the bottom is u to the minus 2 du. So 1/2, 1 more than minus 2 is minus 1, so I have to divide by minus 1. So it would be u to the minus 1 over minus 1 plus c, which is minus 1 over 2, and the u to the minus 1 is u in the denominator, plus c. And then going back to what u was, that's going to be minus 1 over 2 times u, which is 1 plus sine 2x plus c. Well, integral of secant tangent, that's the derivative of secant. But just what times this? So this is a little strange here. But we might try just letting u be secant theta minus 1. Let's let u be secant theta minus 1. So the derivative of secant is secant tangent. And the 1 is going to be 0. So this might work out pretty well. If u equals, the derivative of this is secant theta tangent theta d theta. And so if I solve for d theta, it's going to be du over secant theta tangent theta. So this would become the integral. Now we got the secant theta tangent theta times u, and du is over secant theta tangent theta. So these cancel, and so I just got the integral of u du. Well, that would be, going from 1 to 2, that would be u squared and dividing by the 2 plus c, so it would be 1/2 u, which is secant theta minus 1 squared plus c. All right. Well, the derivative of this is going to be 2x plus 2. If I factor out a 2, it's going to be x plus 1. Oh, so I think I want to leave u be that. U equals x squared plus 2x. Du equals 2x plus 2 dx. So dx is du over 2x plus 2. So this becomes the integral of x plus 1 e to the u, and dx is du over 2, and if I factor out a 2 times x plus 1. X plus 1's cancel. The 2 comes out as a half. Integral of e to the u du, which is 1/2 e to the u du. Going back to the x's, it would be 1/2 e to the x squared plus 2x plus c. Oh, no du here, plus c, sorry. Got going too fast. Okay. All right. 69. Well. Looks like we got e to the t. You got to be able to think of this flexibly. This could be e to the 2 to the t, or it could be e to the t squared. And if I think of it this way, I've got something squared plus this, the something, two of the somethings plus 1. That factors to e to the t plus 1 times e to the t plus 1. Let's see if that works. E to the t times e to the t is e to the 2t, because you add the powers when you multiply. And this be e to the t, this would be 1 e to the t, so that's 2 e to the t's, and 1 times 1, 1. So if I let u be e to the t plus 1, du would be e to the t, derivative of 1 is 0, dt, solving for dt, du over e to the t. So this integral becomes the integral, I'll leave the e to the t there momentarily, dt is du over e to the t. That's going to cancel those. And down here, this is u squared. So this becomes the integral of u to the minus 2 du, which, raising that by 1, is minus 1 minus, divide by minus 1, and u to the minus 1, which is plus c, which is minus 1 over u plus c. Going back to the t's, this would be minus 1 over e to the t plus 1 plus c. Now this one, they say let u be 1 plus the square root of x. So du would be, derivative of 1 is nothing, x to the 1/2 derivative would be 1/2 x to the minus 1/2, which is 1 over 2 square root of x dx. And so dx becomes 2 square root of x du. So this would become the integral dx would be 2 square root of x du, dx would be that, change to that, over u cubed. What are we going to do? Well, let's solve for the square root of x. It would be u minus 1. The 2 can come out. The square root would be u minus 1 over u cubed du, which we can split that into two integrals. Integral of u over u cubed minus the integral of 1 over u cubed. And so this is the same as u to the minus 2. And minus 2, this is the same as the integral of u to the minus 3. So this becomes 2. Add 1, so it's minus 1, and divide by minus 1, so which is just like a minus, u to the minus 1 minus 2. So this, we increase by 1, would be minus 2, so we got to divide by minus 2, u to the minus 2, c. And so we get minus 2, the u would go in the denominator, and that's 1 plus the square root of x. And the minus minus becomes plus, and the 2's cancel, and then we'd have a u squared in the denominator, so 1 plus the square root of x squared. $77. They said, do this, letting u be sine of x, and then let it be cosine of x. So if u is sine of x, du would be cosine x dx. So I would replace dx with du over cosine x. So this would become the integral of u cosine x dx would be du over cosine x. And the integral of u is 1/2 u squared plus c. So this would be half of u is sine x, so that'd be 1/2 sine squared x plus c. If we did it with u being cosine of x, du would be, derivative of cosine is negative sine of x dx. So we'd get the integral of, we leave the sine of x there, the cosine is our u, and du over negative sine x is what I'm going to put in for dx. And the sine x's cancel, and so I get the negative can come out, the integral of u du, which is negative 1/2 u squared d plus c, which should be negative 1/2 cosine squared x plus c. And it says, why are these? How do we reconcile the difference here? Well, let's see. Cosine squared is 1 minus sine squared. So minus 1/2 times 1 would be minus 1/2. And minus a minus sine squared would be plus 1/2 sine squared x plus a constant. Well, that looks exactly like this, except it's got a minus half added to a constant, which is just a different constant. So this is just the what this constant would be is whatever that constant is minus a half. And so they're the same. 87. Well, it turns out the derivative of x squared plus 2 is 2x, and the x's would cancel here. So that's what I'm going to let u be. U is going to be x squared plus 9, so du would be 2x dx. dx would be du divided by 2x. So I'd have the integral, if I'm changing to u, 0 would be 0 squared plus 9 is 9, and 4 would be 16 plus 9, 25. I've got this x, but I'm changing this to square root of u, or u to the 1/2. du would be over 2x, dx be du over 2x. The x's cancel, so I got a half. Integral of u to the 1/2 would be, add 1, would be 3/2, divide by it, so it would be 2/3 u to the 3/2. And since I changed the variables, I could stay in u, from 9 to 25, which is going to be square root of 25 is 5, cubed is 125. These two's cancel. So I got 1/3 of 125 minus, and I put 9 in there, and square root of 9 is 3, cubed is 27 over 3, which is just 9. And 3 goes into 125, that's 41 2/3. Square 9 is 3, cubed is 27, yep. 27 times a third, yes, 9. So minus 9 is 32 2/3. $89. Well, the derivative of this is going to be 2x squared plus 2, and 2 could come, 2x plus 2, which is almost the same as that. So I'm going to let u equals x squared plus 2x. du is going to be 2x plus 2 dx. So if I divide by this, I'm going to get du over 2x plus 2, which is 2 times x plus 1, is what dx is going to be replaced with. And so this becomes the integral. Change my limits. 0 squared plus 2 times 0 is 0. 1 squared is 1 plus 2 times 1 is 2. So that goes to 3 of, I have the x plus 1. I have this, which is u to the 5th. And dx is going to be du over 2 times x plus 1. So I have 1/2, taking the 2 out. Integral of u to the 5th will be 1 more than 5 is 6. 1/6 u to the 6th. Since I changed my limits, I can just go with 0 to 3. And so I get 1/12 of 3 to the 6th minus 1/12 of 0. So it's 1/12 of 3 to the 6th. One of the 3's would cancel, so that'd be 1/4, 3 to the 5th. And 3, 9 is 2, 3 is 27, 3 is 81, 5 is 243 over 4. Or 4 into 24 is 6, D and 3/4. $90. Well, if we let u equal x minus 9, then du will equal dx. And this would change to, if I put 10, 10 minus 9 is 1. If I put 17, 17 minus 9 is 8. And it would be u to the negative 2/3 du is dx. And if I increase negative 2/3 by 1, that would be 1/3, and dividing by 1/3 would be 3u to the 1/3, evaluated from 1 to 8. The cube root of 8 is 2, times 3 is 6, minus cube root of 1 is 1, times 3 is 3. $93. The derivative of tangent squared is 2 theta. So derivative of theta squared is 2 theta. That would cancel that, so I'm just going to let u, actually, yeah, I'll let u be actually, I'm going to let it be tangent, no, I'm going to let it be theta squared. So du is going to be 2 theta d theta. Now, it's not going to solve my problems here yet, but a little help out here. So if I put in 0, 0 squared is 0. And if I put in 1, 1 squared is 1. And it's going to be theta tangent of u, and du over 2 theta is d theta. So it's going to be du over 2 theta. Thetas cancel. So now I've got the integral from 0 to 1, and that's changed. They didn't change. They look the same, but they're changed. Of tangent u du. But what the heck is that going to be? Well, if we think of tangent as sine of u over cosine of u, we could let another variable like v maybe, or w, be either sine of u or cosine of u. And the derivative of sine of u would create a cosine in the denominator, which we wouldn't want necessarily. But if we let u be, or the variable be cosine, its derivative would produce a sine in the denominator, and that looks more productive. So I'm going to I'll do w just so it's easier to see. I'll let w be, cosine of u. So dw would be, the derivative of cosine is negative sine of u du. So I'm going to replace du with dw over negative sine of u. So this is going to become, see, changing the limits here now, cosine of 0 degrees, or 0 radians, is 1. And the cosine of 1 is cosine of 1, not a nice number. And this would be sine of u, and then we'd have du, which is going to be dw over negative sine of u, and then cosine is w. So this cancels with this. A negative comes on the outside, so I'm going to have minus the integral of 1 to cosine of 1 of 1 over w dw. Well, that's just ln of w, an absolute value, evaluated from, and that's going to be minus, and from 1 to cosine of 1, which is going to be minus ln of cosine of 1. Well, that's a positive, so I didn't need the absolute value. Minus, and the ln of 1 is 0. So we get minus ln of the cosine of 1. Okay, next one. Well, if I let u be cotangent of x over 2, then its derivative is cosecant, negative cosecant squared, which would cancel that. So I'm going to let u be cotangent of x over 2. So du would be the derivative of cotangents, negative cosecant of x over 2 times the derivative in the inside, which is 1/2 dx. So dx would be replaced with negative 2 du over cosecant of x over 2. Oh, excuse me. Derivative cotangent is cosecant squared, so it would be cosecant squared, which is what I wanted it to be because I wanted to cancel it. Forgot the squared. Okay, so this would become, if I put pi over 3 in there, this would become pi over 6. Cotangent of pi over 6. So on the unit circle, pi over 6 is right there. The tangent be 1 over the square root of 3, so the cotangent square root of 3 over 1, or just the square root of 3. So pi over 3 becomes cotangent, pi over 3 in half is pi over 6. Cotangent would be square root of 3 over 1, which is the square root of 3. And in pi over 2, cut in half is pi over 4, and so the tangent is 1, and so the cotangent is also 1, because the reciprocal 1 is 1. We have the cotangent squared, which is what we let u be, so we got u squared cosecant squared of x over 2. Dx is going to be replaced with minus 2 du over cosecant squared of x over 2. Unfortunately, because of our choice of u, those cancel. We can pull the minus 2 out. And the integral of u to the second is, raise that by 1, 3, divide by 3, u to the third. Since I changed the limits, I can just evaluate that from the square root of 3 to 1. If I put 1 in there, I get minus 2/3. Minus, and if I put the square root of 3 in there, we have the square root of 3 times the square root of 3 times the square root of 3, 3 times the square root of 3, times a negative 2/3. The 3's cancel. So I get minus 2 square root of 3. That becomes plus. So we get minus 2/3 plus 2 square root of 3. All right. Well, if I, on this one, let u be f of x, du would be the derivative of this, f prime of x dx. So dividing by f prime of x, du over f prime of x is what I'll replace dx with, and so this becomes the integral of u to the third f prime of x dx is du over f prime of x. The f primes cancel. The integral of u to the third is 1/4 u to the fourth plus c. So, and u was f of x, so this is 1/4 f of x to the fourth plus c.